Welcome to the University of Idaho Extension's Pesticide Safety Education Program. In this course, you will develop basic math skills for calculating accurate pesticide applications. You will also perform calculations using real equipment calibration examples. While watching, please remember that you can pause the video for additional time to read and review the written content on the screen. You may also rewind the video at your convenience to rewatch anything you have already seen. Please read the disclaimer before continuing the course. Along many of the sidewalks you maintain for your clients, purslane is growing up through the cracks. Pulling these weeds only encourages their growth. You decide you need a better plan to eradicate the weeds. After speaking to your local extension office, you buy a pesticide to spot treat these sidewalks. You decide to use a handheld sprayer because it is easy to set up and perfect for spot treating pesky weeds. Understanding how to calibrate yourself to your equipment is key to making accurate and safe pesticide applications. Calibrating your travel speed to your equipment is essential for distributing a small amount of product over your treatment area, regardless of the treatment area size. By the end of this course, you will be able to determine your swath width, calculate a test plot, identify your travel speed, collect the nozzle output, and compile your calibration rate. There are many reasons to use the correct amount of pesticide. By calibrating your travel speed to your equipment, you will reduce potential damage to people and property, protect your loved ones, ensure an effective application, plus it is cost effective. Click the arrows to see the equipment you will need to calibrate your sprayer. You will use a measuring tape to measure the test plot area and your swath width. Flags are used to mark the area of the test plot. A stopwatch is useful when calibrating your sprayer. You can also use the stopwatch app on your cell phone or a regular watch with a second hand. You will need measuring containers to collect and measure the water spray. Be sure to mark these containers pesticides only. Anytime you work with pesticides, at a minimum you should wear a long-sleeved shirt, long pants, shoes, and socks. Read and follow the personal protective equipment statement on the labeled product. Prior to sprayer calibration, ensure your sprayer is in proper working condition. Check that your nozzle is spraying correctly with consistent pressure.
This video will show you how to check your knapsack sprayer. You will need a clean work area, a clean knapsack sprayer, its instruction book, the nozzle supplied, clean water, detergent, cleaning cloths, screwdriver, a checklist, and your personal protective equipment. When checking your sprayer, only use clean water and wear your PPE so that you get used to wearing it and can adjust it so that you are comfortable. This knapsack has already been cleaned. We show you how to do this in a separate video. Check for any obvious damage. Check that the hoses and hose clips are secure and undamaged. Check to see if the straps and fixing points are damaged in any way. With the tank full of water, lift the sprayer and check to see if the straps and their fixing points are still secure. Next, check to see if the sprayer is stable when lifted and place on a flat surface. With the sprayer upright, check thoroughly for any leakage. Now place it on a slightly inclined surface. If the sprayer falls over easily, then it must be repaired or replaced. Now turn the sprayer onto its side and check for leaks. Then turn the sprayer upside down and check for major leaks. check the pressure relief valve by pumping without spraying to create pressure. Is it opening and letting the water bypass the pump? If you are pumping very hard and the valve is not working, then replace this valve. Open and close the trigger on-off valve. Does it start and stop spraying quickly? If it does not, then it will need to be replaced or repaired. Next, check the nozzle, and if there is damage to the nozzle, replace it. To see how they are fitted, just twist the nozzle cap off, and the nozzle with its nozzle filter and a sealing O-ring can be seen. The filter must be clean as it protects the nozzle from becoming completely or partly blocked. Sometimes the knapsack sprayer will be sold with just one nozzle of an adjustable type. Others may come with different types of nozzles. Using clean water, check that the nozzle that you are going to use produces the correct spray pattern. Remember to mark up your checklist. If you need one, you can download a checklist from our website where you will also find more information about using pesticides and which PPE to use.
When calculating your calibration rate, there are several common measurements you will use. You must determine the test plot area in square feet. You will time your application travel speed, or stride, as feet per second, and collect nozzle spray output in ounces per second or minute. In this process, you are really calibrating your travel speed rather than the equipment. These steps are the measurements required to calculate your calibration rate. First, measure your swath width. Second, calculate the test plot area. Third, determine your travel speed or stride. Fourth, collect the spray or the nozzle output. And lastly, calculate your calibration rate. Let's begin. In this first step, the spray or swath width is measured on the sidewalk or asphalt. It is also a visual to verify your spray coverage. You will use your swath width when calculating the test plot area. To determine your swath width, fill the sprayer with water and walk on the sidewalk or asphalt, spraying in a side-to-side motion. Measure the spray pattern from left to right. This is your swath width. Remember, you will calibrate your stride when you change your nozzle or pressure of the application equipment. In this example, your swath width is 4 feet. Let's practice calculating swath width. When you have your answer, click the Answer button to check your answer and view the solution. When you are finished, click the Next button to continue. There is one more problem to check your knowledge on calculating swath width. When you have the answer, click on the Answer button to view the solution to the problem. When you are finished, click the Next button to continue. In the second step, you will calculate the length of the test plot using both the total test plot area and your swath width. The test plot is a fixed space that demonstrates the time required for an application. Choose an appropriate total test plot area that is between 100 and 1,000 square feet. In the previous example, you measured the swath width. This measurement, along with the chosen total test plot area, is inserted into the formula. Simply divide the total test plot area by the swath width to determine the length. In this example, divide 100 square feet by 4 feet. The test plot length equals 25 feet. Then flag the test plot at 4 feet by 25 feet, creating a rectangular test plot area. Let's practice calculating the test plot area. When you have your answer, click the Answer button to check your answer and view the solution. When you are finished, click the Next button to continue. There is one more problem to check your knowledge on calculating the test plot area. When you have your answer, click on the Answer button to view the solution to the problem. When you are finished, click the Next button to continue. In this third step, knowing your travel speed or stride is key to a consistent application. You'll want to practice this stride so it becomes second nature. You will time your stride while spraying water over the test plot area. Fill your sprayer with water and walk the test plot while performing a water application. Clock your time and repeat 3 times to find your average. In our example, your average application of 400 square feet was 50 seconds. Let's practice calculating your stride. When you have your answer, click the Answer button to check your answer and view the solution. When you are finished, click the Next button to continue. One more problem to check your knowledge on calculating your stride. When you have your answer, click on the Answer button to view the solution to the problem. When you are finished, click the Next button to continue. Measuring the nozzle flow rate, or nozzle output, is the fourth step. In this scenario, you will quantify the amount of water distributed over a certain amount of time. In the previous example, you recorded the time it took to walk the test plot area while spraying. This step uses that same recorded time to collect and measure the nozzle output. The collection of the water spray is simulating the nozzle output from the previous step. The collection time is equal to your stride. We will collect the water from the nozzle in a measuring container for the amount of time it took to walk the test plot. In our example, you walked 35 seconds, so collect the water spray for 35 seconds. When you are finished, you measure 4.75 ounces. This means you cover 400 square feet with 4.75 ounces of water. Let's practice collecting the nozzle output. When you have your answer, click the Answer button to check your answer and view the solution. When you are finished, click the Next button to continue. There's one more problem to check your knowledge on collecting the nozzle output. When you have your answer, click on the Answer button to view the solution to the problem. When you are finished, click the Next button to continue. In this last step, calculating your calibration rate ensures you are distributing the correct amount of product over the specified area. It is specific to your stride, the equipment's nozzle pressure, and flow rate. The calibration rate is the amount of product you distribute over a specified area. It is a compilation of the previous measurements that identifies the coverage of your application. In this example, the test plot is 400 square feet. You traveled this space in 65 seconds. After collecting the nozzle output for the same recorded time of 65 seconds, you measured 9 ounces. This means you are calibrated to apply 9 ounces of water over 400 square feet. Let's practice calculating your calibration rate. When you have your answer, click the Answer button to check your answer and view the solution. When you are finished, click the Next button to continue. One more problem to check your knowledge on calculating your calibration rate. When you have your answer, click on the Answer button to view the solution to the problem. When you are finished, click the Next button to continue. Remember these tips when calibrating yourself. Inspect your sprayer before calibrating your equipment. Check your sprayer for proper coverage. Measure your test plot area. Record your stride to get a consistent travel time. And watch your speed. If you increase your speed, you will apply less product. If you decrease your speed, you will apply more product. Let's take a moment to review what we have learned. Our program is grant-funded, which allows us to offer courses such as this one. To continue producing educational modules such as this one, we ask that you take a moment and complete a short 7-question survey. Your answers are anonymous and will help us improve our future courses. Thank you for your help. Congratulations! You have completed the Calculate Pesticides Using Sprayers module. To properly exit this training, make sure to click the Exit Activity button at the top right of your screen to record your survey submission and to properly exit this course. Failure to click the Exit Activity button can result in not tracking your course completion.